Hello, everyone. My name is Julia from Wushin Networks in South Korea. Today, I am excited to introduce an innovative solution that's making a significant impact on the network market in South Korea. The solution is called Electronic Patch Switch, commonly referred to as EPS. This solution was developed in South Korea and has been widely adopted by many large enterprises here. It has gained significant popularity and is now considered the top choice when implementing new network infrastructures. Due to its remarkable success in the Korean market, we believe it's a good time to share the benefits of this solution with potential international customers. I hope this presentation helps you discover and understand how EPS can bring value to your network environment. Now, let's dive into what EPS is and how it can make a difference. We have prepared the agenda as follows. First, I will introduce the key benefits of EPS. Next, we will go over the solution overview, followed by a detailed introduction. Then, we will discuss the business impact and share a few real-world use cases, along with key customer references. Finally, we will wrap up with key takeaways. Let's get started. Let me briefly explain the key benefits of EPS. EPS provides three main benefits: functional, operational, and financial. First, functional benefit. For critical systems with only a single LAN port, if the directly connected switch fails, it can be very challenging to handle the issue quickly and effectively. EPS addresses this by enabling redundancy, reducing the risk of service downtime. For highly critical single LAN port devices such as industrial equipment, PLCs, important servers, and so on, EPS helps improve both service availability and reliability. Second, operational benefit. Leveraging the functional advantage, EPS offers two key operational improvements. First, during preventive maintenance, single LAN port devices can remain fully operational without any service downtime. Second, when a switch connected to single LAN port devices fails, immediate recovery can be difficult in certain environments. For example, remote sites, unmanned facilities, nighttime failures, or locations with complex access procedures. In such cases, downtime may last much longer than expected. EPS ensures service continuity even in these challenging environments. Third, financial benefit. Customers may consider purchasing additional LAN ports for redundancy via teaming or bonding. However, in many cases, especially with industrial equipment, LAN ports are quite expensive. EPS eliminates the need for a costly second LAN port for teaming or bonding, while still providing the same level of redundancy. EPS offers a simpler and more affordable redundancy solution, replacing the need for teaming or bonding. In summary, EPS not only enhances service availability and reliability, but also reduces operational complexity and financial burden. Next, I'd like to discuss the background and purpose of EPS development. The primary motivation was to solve a challenge faced by critical single LAN port devices, especially industrial equipment and important servers, where any service disruption can lead to serious consequences. If a switch connected to single LAN port devices fails, it inevitably causes service downtime. However, by deploying EPS with a backup switch, we can enable automatic failover in the event of the access switch failure. This ensures uninterrupted service, even during unexpected network issues. Depending on the network environment and the EPS models, several deployment options are available. We'll see more about this later in the presentation. Now, let me explain the EPS solution in more detail. EPS is a hardware appliance type solution. As shown on the left, EPS is designed to provide redundancy between single LAN port devices and access switches. Normally, a patch panel is installed between endpoint devices and access switches for physical connectivity. As you can see on the right, EPS can replace the patch panel, while also adding redundancy and resilience. It continuously monitors the link pulse signal from the access switch. If the signal is lost, EPS automatically triggers a failover to the backup switch. Based on our field experience, the failover process usually completes within 3 seconds, and at most within 5 seconds. Additionally, even if the EPS loses power, the auto bypass function ensures that the service remains uninterrupted. As mentioned earlier, the key benefits are uninterrupted network operations and zero downtime preventive maintenance. Next, I will explain the architecture of EPS. EPS supports two types of redundancy: N-to-1 shared backup and 1-to-1 dedicated backup. Let's first look at the N-to-1 backup architecture shown on the left. This model includes a built-in switching chip. It can aggregate traffic from either 24 or 12 active ports into one backup port depending on the EPS model. If a port or multiple ports fail, EPS redirects the traffic through the backup port. Normal ports continue operating as usual. One thing to note is that you don't need the same number of backup ports because the traffic is aggregated. Now let's look at the one-to-one backup model on the right. This is simpler, each port has its own dedicated backup port. The current model supports 24 active ports and 24 backup ports. Because this model does not aggregate traffic, the backup switch should have the same number of ports. When choosing between N-to-1 backup and one-to-one backup model, both technical and financial factors should be considered. The N-to-1 backup model allows a single compact 1-rack unit switch to serve as a backup switch, but this EPS model is more expensive than one-to-one backup model due to its built-in switching chip. In contrast, the one-to-one backup model requires a backup switch that has the same number of ports, but this EPS model is less expensive than the N-to-1 EPS model. Additionally, the cabling costs should also be taken into account. Therefore, the most cost-effective solution depends on the customer's network environment and specific requirements. Next, let me introduce the EPS Management System, or EMS for short. This EMS enables real-time monitoring of both active ports and backup ports on the EPS. Users can access the EMS server from client devices such as PCs or laptops. Since EPS supports SNMP, it can also be integrated with the customer's existing NMS. This allows EPS to be centrally managed with other network devices. Now, let's move on to the EPS product lineup. There are 2 models for N-to-1 backup, and 1 model for one-to-one backup. The first N-to-1 backup model is EPS 4810TS. It's a 2-rack unit device that offers 48 UTP access ports and 2 1G UTP or 10G optic uplink ports. This is 24 access port to 1 dedicated uplink model, and it works like 2 stacked 24-to-1 EPS units in a single device. This model requires an external 24 volts DC power supply, which will be discussed in the next slide. Additionally, this model has a PoE option, enabling PoE devices to benefit from the redundancy provided by EPS. The second N-to-1 backup model is EPS 1200TS. This model is a 1-rack unit device that provides 12 access ports and 1 dedicated uplink port. This is a high-end model supporting up to 10G access ports and 40G uplink port. It includes built-in AC power supplies. DLS 2400 GT is the only one-to-one backup model. This is a 1-rack unit device that offers 24 access ports and each directly mapped to 24 backup ports. It also includes built-in AC power supplies. All 3 models have 1 management and 1 console port for configuration and monitoring. This slide is about the power supply units for the EPS 4810TS, converting AC to 24 volts DC. FPS 1000 is 1-rack unit, and it supports up to 4 EPS 4810TS units. FPS 2000 is 2-rack unit, and it supports up to 12 EPS 4810TS units. FPS 300 is 1-rack unit, and it can support 1 EPS 4810TS unit. One of the EPS features is that even if the power supply unit fails and power is lost, the system automatically switches to the auto bypass mode. This ensures that the service remains uninterrupted during a power failure. Next, let's look at the business impact of deploying EPS. When a single LAN port device is connected to an access switch, the following service disruption scenarios may occur. Case 1. A specific port on the line card fails and cannot be recovered immediately. Case 2. The supervisor card or a line card fails and cannot be recovered immediately. Case 3. The entire chassis fails and cannot be recovered immediately. Without EPS, the recovery procedure involves: first, failure detection and situation awareness typically takes about 10 minutes. Second, traveling to the site may take 20 to 50 minutes depending on distance and traffic. Third, switch replacement and recabling can take 10 to 60 minutes depending on the situation. Total service downtime can range from 40 to 120 minutes. With EPS, failure detection and failover occur automatically within 5 seconds. There is no service disruption, and the faulty switch can be replaced at any convenient time. Next, let's talk about the situations related to preventive maintenance tasks. OS upgrade due to access switch bugs may require up to 120 minutes of downtime. Power shutdown for access switch dust removal may require up to 60 minutes of downtime. Periodic rebooting of access switches may cause up to 10 minutes of downtime. Line card replacements for upgrade may require up to 20 minutes of downtime. With EPS, the downtime in all of these cases is reduced to less than 5 seconds. In the past, the customer avoided rebooting access switches connected to critical systems for years, due to concerns over unexpected reboot failures. In some cases where a reboot was forced, the access switch occasionally failed to restart correctly, which resulted in extended downtime. Since EPS was deployed, such incidents have been dramatically reduced, significantly improving network availability and reliability. EPS not only provides robust protection against unexpected failures but also enables zero downtime maintenance, ensuring a stable and continuous service. Next, let's take a look at some key real-world use cases. I will walk you through 5 examples. Case 1 is manufacturing plant. At this manufacturing site, system controlling and environmental devices depended on a single monitoring connection to an access switch. If that switch failed, monitoring functions were completely lost. After deploying EPS, fast automatic failover was enabled, ensuring uninterrupted monitoring and control. Because the network between the access and distribution switches was layer 3, they implemented HSRP or VRRP to maintain continuous routing and redundancy. Additionally, the customer takes advantage of EPS for online maintenance activities such as replacing discontinued equipment. The second case is similar to case 1. The key difference is that it was L2 connection between the access switch and distribution switch, where the spanning tree protocol is active. In this setup, it is critical to manage the STP blocking port properly to enable fast service activation during failover. One thing to note is that the EPS system is free from spanning tree protocol, meaning there is no need to worry about L2 loops due to EPS. The third case involves a critical wireless infrastructure. For the critical industrial systems such as AGV and OHT, Wi-Fi redundancy was essential to ensure stable operation. Previously, the redundancy was achieved by adding extra PoE switches and redundant access points. However, after deploying EPS, the customer was able to eliminate the need for additional PoE switches and redundant access points. Since EPS supports PoE, the customer could use a non-PoE access switch along with a non-PoE backup switch. As a result, they achieved significant cost savings while maintaining the same level of service availability and reliability. The fourth case involves a server farm network where critical servers were connected to a single access switch. Due to the importance of these servers, the customer considered purchasing additional LAN ports to implement teaming or bonding. They also planned to purchase backup switches with the same model and number as the access switches. However, after evaluating the costs, they chose to deploy the end-to-one backup EPS because it was far more cost-effective while providing the same level of redundancy. EPS offered a more economical approach without compromising service availability and reliability. The final case involves an ISP that operates unmanned remote sites. Previously, unmanned sites had a switch that handled traffic from multiple subscriber networks through a single uplink. In the event of the switch failure, a maintenance engineer had to travel to the site to replace the failed switch with a pre-configured backup unit. The process resulted in significant service downtime. Because of this, the customer had difficulty meeting SLA and there was a risk of customer dissatisfaction and churn. To resolve this issue, the ISP deployed EPS and eliminated all the risks associated with switch failures. In this case, the switch was configured as layer 3, with each port assigned a unique IP address. They deployed the one-to-one backup model to support this configuration. Let me share some of the major customers in South Korea who are currently using EPS. EPS has already been successfully adopted by many leading manufacturing companies, including major conglomerates such as Samsung, SK, and POSCO, as well as Korea's largest ISP provider, Korea Telecom. With growing awareness of its benefits, we expect more customers to adopt EPS moving forward. Today, I introduced an innovative solution called the electronic patch switch, or simply EPS. Let me briefly highlight the key benefits once again. Number 1. Functional benefit. EPS enables redundancy for single LAN port devices, eliminating the risk of access switch failure, which is a single point of failure. Number 2, operational benefit. First, during preventive maintenance, critical single LAN port devices can remain fully operational without service interruption. Second, in the event of access switch failures, EPS automatically triggers real-time failover, ensuring service continuity. This removes the need for immediate response in challenging situations. Number 3, financial benefit. EPS significantly reduces costs compared to teaming or bonding configurations with additional LAN ports. It is a highly cost-effective alternative that offers the same level of redundancy. Thank you for staying with us until the end of the presentation. It's been a pleasure sharing this with you, and we hope you've gained valuable insights into the advantages of the electronic patch switch. We encourage you to experience the benefits of EPS and enhance your network availability and reliability. If you have any questions about EPS, please feel free to reach out to us using the contact information provided below. We look forward to helping you maintain better network service and a more resilient network. We truly appreciate your time and interest. Thank you.